Chapter 3, Quadratic Functions. Section 3.1, Investigating Functions in Vertex Form. Okay, so basically what this section is going to be about is talking about quadratic functions specifically, but talking about them in this form right here. This is called vertex form. So we're going to talk about which each variable represents, where each parameter represents, and why this is useful, and do some problems with it. So first of all, you should read through the notes, look at the applications of quadratic functions. I'm going to skip ahead to what a quadratic function really is. Basically, it's a degree 2 polynomial. So you can see here, with the x value has degree 2. That is, it's raised to the power of 2. They all will look like the picture right here. Okay, they'll either be wider or narrower, depending on one of the parameters. Okay, they'll shift up and down, left and right, depending on some other parameters. But basically, here's the shape. So you can see, if you look at this one right here, it really looks like, for instance, a ball being flung into the air, and it will follow some kind of parabolic flight pattern. So, something that's very important is that they're all symmetric, okay, about some kind of imaginary line that's called the axis of symmetry. As you can see, in the axis of symmetry in this example below is x equals 3. They also have a vertex, okay? This point will be either the maximum or minimum value, okay, of the parabola of the function. Here, this would be a, what do you think it is? A minimum value, okay? The whole graph is symmetric about the vertex and the axis of symmetry, okay? Here's the formula for vertex form. The reason this is called vertex form is because P and Q are what the vertex is, and you can get them by inspection. You literally can just read them off. That makes this form very useful when you want to graph it, because you instantly know the vertex. It's very simple to find an additional point, and then you can use the axis of symmetry to find the other point, and there you can graph it or sketch it very quickly. This slide is dedicated to talking about transformations. I'm not going to get into this. This is basically the gist of, or the bulk of pre-calculus 30, but here's another way of graphing functions, of thinking about functions, that's very useful, a bit more complex, but it relates everything back down to the base function x squared. In pre-calculus 30, you won't be limited to just quadratic functions. You'll deal with a whole other slew of functions. Okay, let's move on. Very quickly, domain and range. Domain are all the possible x values for which f of x is defined. In quadratic functions, this is absolutely the case for every single example. X is an element of the reals. You read this like x such that, that's what this little line means, such that x is an element of the real numbers. Y will depend, so the range is all the possible y values which result from f of x. It will depend on how much the graph is shifted up or down. Here it's at 0, that means y is basically all of these values. Okay, y is all of the values above 0, so y is greater than or equal to 0. This is included because it's telling the reader that in this right here, you're dealing with the real numbers, right? You're not dealing with integers, you're not going up by some kind of discrete amount, okay? So it's continuous. That's important as well. So let's get to an example. You can look at example 1, look at the work, but I will do the practice problem. So the practice problem says determine the following characteristics for each function: the vertex, the direction of opening, the domain and range, the equation of the axis of symmetry, and then finally it asks to sketch it. So let's do y equals 1/2 x minus 2 squared minus 4. Okay. So here we have it written out for us. Step 1 will be to find the vertex. Okay, that's very simple. We can get this through inspection. The vertex here will be 2. Okay, remember this is P right here. Okay, and this is Q. So it'll be 2 and negative 4. Now right away in my notes I actually find another point quite quickly, okay? Because you're going to need at least 2 points. You need the vertex and you're going to need another point to be able to sketch it. I'm going to omit that for now and move on to the next question, which was, I believe it was to talk about the direction of opening or the domain and range. Doesn't matter. Here a equals 1/2, which is positive. Sorry. Which implies we are opening upward. Right? Since we're opening upward, that would also mean that we have a minimum value. So here, this is actually a minimum value. You can kind of imagine what this graph is going to look like already. The next question, look for the domain and range. The domain is always this. X is an element of the reals. The range, since it's a minimum value, since it's opening upwards, the vertex is the smallest point. We're looking at y values here. So it'll be y such that y is greater than or equal to -4. Once you see the sketch, this will become clear, but you can do this without sketching it, just by visualizing the graph. Oh, and I'm sorry, you have to also include that y is an element of the reals. It's not the end of the world if you forget this, but it's important. Okay, so we also need to figure out the axis of symmetry. The axis of symmetry will equal 2 in this case. Okay, x equals 2. So really this is x equals 2. That comes from the vertex. So you remembered when I showed you the picture, the vertex, the x coordinate of the vertex is always the equation of the axis of symmetry. So given all that, we should be able to sketch a very neat graph. We're missing 1 point, like I said. We need to find another point in the graph. I'm going to sketch what we have so far. We have 2 and 4. We're at this point. Okay, it's going to open upward. So you can see that we need another point to know how wide or narrow this graph is. And you can choose any point you want by plugging in some kind of point, but I'm going to choose something called the y-intercept. So I'm going to find the y-intercept, which is when x is 0. So I'm simply going to plug in x equal to 0 in the above graph, or the above function, which gives -2, right? This is 4 divided by 2 is 2, minus 4 is -2. So now I have another point. I have the point 0 and -2 to work with. So that would be roughly around here, not the greatest sketch. Now remember, the axis of symmetry is right on the vertex. And here's how you get your third point. You're going to look at the point that's equidistant, this distance, on the opposite side, giving us a lovely and hideous sketch. I'm sorry, but you get the idea. That will go through both of those points. Okay, if you wanted to be more precise, you can choose more points for x. Choose more values for x, plug them in, and then plot them equidistant from the axis of symmetry. So that's how you do that. Okay. So I'll leave B to you. So, and B is exactly like this question, except it opens downward. Okay. Now example 2 here is if you're given the graph. Okay, so you can see the work I did for this. Here's the practice problems. If you're given the graph, go to vertex form. This isn't so bad because let's look at A right here. And I'm going to switch to green. If you're given, this is the vertex, right? That's the vertex. This is a maximum value. So here the vertex is equal to -3 and 0. Right? That's what the vertex is equal to. This gives you a couple values. This gives us P equals -3 and Q is equal to 0. That's going to come important later on. and important to remember what vertex form is. So there's vertex form written up there. You're given P and Q, you actually don't know what A is. That'll be the tricky part. So to find A, you're going to have to be a bit clever. You're going to have to plug in any point on the graph for X. So for instance, if you take a couple points that are listed, take this point right here. That is the point X. Sorry, what point is that? That's the point. Let's see. Move this over. That was the point -1 and -2. -1, -2. What you're going to do is you're going to plug this into the formula. Okay, so for instance, -2 will go in for y. It's going to equal a. You're going to have -1 for x minus p all squared plus q, which is 0. You're going to solve for a and then you're done. Then you'll have the answer. Here we have -1 plus 3, which is going to be 2. Squared is 4, so you have -2 equals 4a. That's 0. So here a is equal to -1 over 2. Okay, which makes sense because it's opening downwards and it's quite wide. Okay, therefore your answer to this question is y, or f of x, whatever you want to put, is equal to -1 over 2 x minus p, so you're going to go plus 3 because the negatives will cancel, all squared, and that's it because q is 0. That is the quadratic function in vertex form for this graph. So this next one, you look over here, that vertex right there is 2 and 1. If you take another point over here, this point is 3 and 5. So very, very quickly, you can immediately plug in. Right? You can immediately go to 5 equals a. You're plugging in the vertex. Sorry. Hopefully this doesn't. There we go. For x, you're plugging in this value right here. So it's 3 minus p, which is 2. I'm doing this all in one step here. Plus 1 is q. Now we can solve. So we have 5 equals 3 minus 1 is 1. 3 minus 2 is 1. So what we're left with is a plus 1. So here a is equal to, hey, come back. A is equal to 4. Which makes sense because it's narrow and it's open up. Therefore, your graph is y equals 4 times x minus 2 all squared plus 1. Just like that. Okay? Now, let's move on to the very last question. The very last question asks for intercepts. It says determine the number of x-intercepts for each quadratic function without graphing. So it's a quicker question, actually. Without graphing, you should be able to tell me how many x-intercepts there are. What that means is an x-intercept is the points, like this, that cross the x-axis. Okay? It doesn't just have to cross, though. It can touch the x-axis, and that would be something like this. That counts as an x-intercept. Okay? It touches the x-axis. So you can see the examples are quite thorough in the solutions when I give you the questions beforehand, right, for these examples. The practice problems hopefully will be a breeze after you look at those examples. So how are we going to do this? Let's look at the first one. Let's look at part A. Okay, f of x equals 0.5 x squared minus 7. Okay, so how many x-intercepts are there? You have to find the vertex. That's the only way you have to do this. The vertex in this question is actually going to be 0 and -7. You can tell that because it's just x, right? There's no terms right here that will give you an x value. Now that you know that it's 0, -7, kind of figure out what quadrant that's going to be in. Okay, or it's not, sorry, not what quadrant it is, but where with respect to the x-axis is that? That's the point. This is clearly underneath the x-axis. Now it says it doesn't. It says don't sketch, don't graph it. Okay, but I'm just going to briefly show you where we are. Okay, certainly on an exam you could always sketch something out just to see where we are. So let's say -7's over here. If it opens upward, there'll be 2 x-intercepts. If it opens downward, there'll be 0. We can figure that out. Here, a is equal to positive, I'll put a positive to stress that, 0.5. Therefore, it opens upward. Opens up, so it looks something like that. It's supposed to hit this. Here, I'll put the point down here. So therefore, there are 2 x-intercepts. And that's it. So do that for each one. Pretty easy, right? So for B, you look at what you have here. The vertex is -1. And don't be deceived, right? In our formula, it's x minus p. So if it's a positive, that means p has to be negative. And 0. So again, if you just do a little brief sketch, we are right here. We're on the x-axis, which means we, at most, can only have 1. It doesn't matter what this opens. We already know the answer. Okay? It will open downward because you can see that a is -2, but that doesn't matter. Here we only have 1 x-intercept. Okay, 1 x-intercept. And then of course for the final one, to finish off this video, you can already tell me the answer here. We have -5 and -1. That gives us a value roughly around here. Hey. Right there. It opens downward. So guess what? Poor writing. I apologize for the writing, but you get the idea. This guy has 0 x-intercepts. Okay, so I think it's should be pretty straightforward. It's pretty very logical chapter and how it works. Vertex form is very important. The next section we're going to do standard form, which is very important as well. But definitely do these practice problems. You need to be very, very good with vertex form as we move forward. It's a very useful form. Hopefully that made sense. Work on the practice problems and ask me if you have any questions.